So, good evening, everyone. So we'll wait for a couple of minutes for other people to join. 10 minutes will wait. So I hope the audio is clear to everyone, right? Everyone can hear the audio, right? Yeah, thanks. So we'll be starting in a couple of minutes, right? We'll wait for more participants to join. Yes, sir. Yes, sir. So let us start. So good evening, everyone. Myself, Bharat Dao. I am a doctoral student at the Department of Chemical Engineering, IIT Kanpur, and also a PMRA fellow. First of all, I would like to thank all of you for attending this session, and I would also like to thank the NPTEL team for providing this platform to teach. We will be starting with the material for the fifth week of the NPTEL course of thermodynamics of fluid and fluid mixture. So I hope you will be understanding but the sample problems, and these sample problems will help you in solving your assignment. Okay, so let us start. The first, the first question for today is, so before we start, so if anybody of you have any doubts regarding previous classes, any class till now, you can ask, and I'll wait for a couple of minutes. You can even write it in the chat box, or even you can ask me after the class is over also. Okay, so let us start. The first question for this week is this one. So this week, mostly we are covering the permutation and combination, which you have learned in your maybe 11th class or 12th class. So we'll be just brushing up because we will be going into the statistical mechanics, where we will be requiring. Okay. So the first question is relatively very easy question. So what we have is, for a sequence of n distinguishable objects, the number of different permutations W are expressed as. So remember the objects. Let's say, for example, we have this object 1, object 2, object 3, object 4, like this. We have W such objects. Okay, this is 1, this is 2, this is 3, this is 4. Okay, and then such that we have W, right? And remember that these are the distinguishable objects. That means this is not equal to this is not equal to this, so on and so forth, right? So what we want is, what is the number of different permutations W possible. So the first option is n factorial, other is W factorial, third option is n factorial into W factorial, and the final is all of this. So this is a relatively very easy question, right? So I'll give you a couple of minutes to solve it. Try it out. Okay. Did anybody got any answer? Okay. So the correct answer is option A. Okay. Oh, let me select this. Correct answer is option A. That is n factorial, right? So as this is distinguishable, the number of ways we can put this n. This is n minus 1. This is n minus 3, right? So the total number of ways is n into n minus 1 into n minus 2, like this. There's 2, 1, 2 into 1. So this is the correct answer. So this is nothing but n factorial notification. This is n factorial, right? The correct answer is option A. Anybody got it? Nobody got it? Okay. I hope the solution now is then clear to everyone. If you have any doubt in this, you can ask. Otherwise, we will move on to the next question. Okay. A very simple question. As we progress through the um, class, we'll be solving difficulty level will be increasing. Okay. So this is a very basic question, very easy. Right. So the next question which we have is, let me change the color. Okay. Okay. The next question is, how many permutations or different sequence of? So here it has to be off instead of it's a typo error. So how many permutations or different sequences of the letter of word cricket are there? Okay. So basically CRICKET. So this is the word which we have, and what we want is how many ways we can arrange this. How many words can we form, right? How many permutation of different sequences? Like for example, here we have. So this is a 1, 2, 3, 4, 5, 6, 7. So it's a 7. 1, 2, 3, 4, 5, 6, 7, right? And so this is a 7-letter word. So how many permutations are possible? by taking letter from this word, right? And how many ways can we arrange? Remember. So one hint which I would like to give is here the cricket word has come twice, right? So remember to take this also in account, right? So I'll give you a couple of minutes to solve the questions. And these are the options, right? 2520, 4120, 3100 or 100. Anybody got it? What is the correct answer? So I'll be revealing correct answer now, right? Correct answer is option A, 2520. Anybody got it? Nobody got it. So I hope the solution will be clear when I discuss it. So what is the number of ways? The total number of ways will be 1, 2, 3, 4, 5, 6, 7, right? That means 7 factorial by, for C, it will be 2 factorial because C is repeated. Rest other things are not repeated, right? That means multiplied by 1 factorial, multiplied by 1 factorial. For R, this is for R, this is for I, this is for K, this is for E, and this is for T, right? So that this means nothing but 7 into 6 into 5 factorial by 2 into 1, right? This is nothing but 21 into 5 factorial. What is 5 factorial? 120, right? So basically it will be 120, or should I write like, yeah, this is what 21 0 42 25. Okay, so answer is 2 5 2 0. Okay, here you can also see, okay, the word is the cricket. So we have CRICKET. So this has number, so this represents number of occurrences. Okay, occurrence, number of occurrences, right? So this has come 2 times, R has come 1 time, I has come 1 time, K has come 1 time, E has come 1 time, and T has come 1 time. So the number of ways will be total number of words, which will be 1, 2, 3, 4, 5, 6. But because C is 2 times, we have to include that. So we'll use 7. 7 factorial divided by number of repeated words, right? So C has been repeated 2 times. So for that, 2 factorial. Then rest of the words are unique. So for them, 1 factorial. This will be this one, right? Because this is the standard notation of factorial, right? N factorial is what? N factorial is nothing but n into n minus 1, right? Into n minus 2, like this, till multiplied by 2 multiplied by 1, right? So we just expand 7 factorial. It will be 7 into 6 into 5 into 4 into 3 into 1 into 2 into 1, right? And then 2 factorial, 2 into 1, and rest 1 factorial will be nothing but 1, right? So when you do simplify this, you get W is equals to 2520, like I said here, right? So anybody has any doubt in this? Nobody has any questions? I hope the solution is clear to everyone. If anybody has any doubts, they can ask me. And if anybody would like to write the question solution also, they can write. Okay, I'll wait for documents. And I see no question. So I hope the solution is clear to everyone. So we'll move on to the next question. Okay. So next question is a theoretical question. Okay, and deals with thermodynamics. Okay, a quantity that relates the microscopic thermodynamic property. Remember the word microscopic is my ask. Microscopic thermodynamic property to the macroscopic, right? Thermodynamic property is the option is ensemble, partition function, both, or none of above. If you would have given a little bit of uh, if you have watched the course videos properly, you will be able to answer, right? It's a theoretical question. Okay. So anybody would like to try? Anybody would like to give attempt? What is the correct answer? Correct answer is it ensemble? No. Is it both? It cannot be obviously both, right? None of the above? No. Correct answer is partition function, right? So what is partition function? So what is, first of all, let us discuss what is ensemble. So there are many types of ensembles, right? Like for example, NPT is called as isothermal isobaric ensemble because pressure is constant, temperature is constant. NVT ensemble is canonical ensemble. Number of molecules constant, volume of the system constant, temperature constant. Then NVE, right? Now number of molecules constant, volume constant, and then energy constant. Okay, and then the last is MUVT. This is grand canonical ensemble, right? But chemical potential, volume, and temperature constant. Right? These are the various ensembles. So in all these ensemble, partition function will be different. Partition function, so there is something called as a bridge equation, right? In each and every ensemble. Okay. Bridge equation relates microscopic world with macroscopic world, right? Bridge equation, right? So the bridge equation will be different for NPT, different for NVE, different for NVT, different for MUVT, right? But the so it will be the form of this will be some property is equals to minus kb, that is Boltzmann factor, multiplied by, let's say, temperature or something, into ln of partition function. Okay. So this property will also be dependent on which ensemble we are working. Like for example, when we have NVE ensemble, so here the thermodynamic property will be entropy. This is nothing but minus kb T into ln of, in that case, it will be the partition function of NVE ensemble, right? And partition function will depend on which ensemble we are talking, right? Clearly, option is not ensemble; it's a partition function. So this term right hand side relates to the or let me write it. The ensemble, the partition function for this NVE will be what? Multiplicity, right? It will be the multiplicity, right? Number of ways of arrangement, right? So this is the partition function for NVE. So like this, different partition function will be for NPT, different for NVE, different for NPT. Similarly, property will also change, but the functional form more or less remains the same, right? Okay, so this is the ensemble and partition function. So this right here, this represents the microscopic, right? This is like, for example, this is like number of ways of arrangement of molecules, that is multiplicity, right? And this is the entropy. Entropy is what? It's a macroscopic property, macro with a macroscopic property, whereas this is the a microscopic property. So this, the equation that relates the macroscopic property with microscopic property is called as a bridge equation, and this bridge equation is different for different ensemble. Okay, depends on which ensemble we are using, and it, but the functional form would remain the same, wherein we will have here property equal to some constant multiplied by ln of partition function. Partition function will also be depends on which ensemble we are working on. So clearly this bridge equation quantity. So this is the equation, and the quantity is the partition, right? So correct answer is partition function. Okay, like for example, like here also we have mentioned minus k, right? Maybe t will not be there, right? Minus k into ln omega, right? Anybody has any question? Nobody has any question? So I'll wait for a couple of minutes. If somebody would like to write this down, or if you have any question, you can always interrupt and ask it, right? So I'll wait for a couple of minutes. And for those who have solved and have no doubt, they can go for question number 4. Okay. So I'll wait for a couple of minutes. I see no questions. Anybody has any questions? Okay, so no questions. So we'll move on to the next question. So this is a quite theoretical. This is a descriptive type of a question. So it will take a bit of time of you. So the question is the internal energy. So U represents internal energy. Partition function is Q, and KT is the Boltzmann constant multiplied by temperature. So what we want is relationship between Q and KT. So what will be the relationship between Q and KT? Like what I see said, right? So it might be in different ensemble. So basically relationship between a thermodynamic property and a partition function, right? So these are the various options which we have. So please try to find out the correct answer, right? Basically relationship between, right? Relationship SHIP, right? Relationship between U, this internal energy, and partition function, which is represented as Q. So those of you who know partition function, what is partition function, and common naming convention of partition function, they can also identify what is this U, Q, which ensemble basically we are working on. Right? So I'll give 5 minutes for you to guys to attempt the question. Okay. If you have any questions, you can ask. I hope the question is clear to everyone, right? Yes. So you can just try it. 5 minutes, I'll give. Anybody has any questions? Anybody able to find the answer, right? Okay, so you want to give correct answer. The correct answer is option C, right? Anybody got it? Okay. Okay. So we'll wait for a couple of more minutes. Remember, even if you don't know how to solve it, you can still do unit balance, right? You can just find what is the unit of U, what is the unit of LHS, and what is the unit of RHS. Using that also you can attempt to find, right? That is also one of the way to do it. Anybody got it? Okay, so we'll move on to solving the question. Okay, so what we have, correct answer is option. Okay, so what we have, we want to find the best most likely most probable distribution, and that is given by the Boltzmann distribution. All right. So according to that, so PJ star basically represents what? Probability of having equilibrium. It is also called as equilibrium distribution or the most probable distribution, right? The PJ star is nothing but, according to Boltzmann, is going to be e to the power minus EJ, where EJ stands for the energy divided by KT upon Q, right? And the okay, when we do the so Q, we replace Q will be what? Nothing but summation of the numerator, right? So this is one macro state corresponding to energy EJ, but partition function will have all the micros, right? So we just do the summation. So this is nothing but probability of having a distribution. You can understand it in this way, like let's say for example, you have a coin, right? And so coin can have, and you toss it one time, so you can have head and tail, right? So probability of getting head will be what? 1/2, right? Probability of getting tail will be what? 1/2. So how was this 1/2 form? This 1/2 was nothing but uh, what we can have is so what are the different combinations? So either we can have head or we can have tail. So total number of possible ways are two, right? Total possible ways, right? Right? And this is the probability of having head, which is nothing but one, right? Similar this also. So basically it will be what? 1/1 plus 1, right? So in that case, we can write whatever this is summation 1, right? Like this sort of way. So this is nothing but that way, right? Probability of this is one macro state, and this is total number of ways. Then only we can have a probability, because PJ star has to be between 0 and 1, right? So this is basically a normalizing factor which will make it a probability bounding between 0 and 1, right? Okay, then what will be the average value? Average value will be nothing but probability. So it has to be PJ star, right? Everywhere it has to be PJ star, right? So PJ star multiplied by probability of having that macro state, micro state multiplied by that micro state, right? So U star is nothing but PJ into EG, right? Summation of PJ into EJ. So when you put the value of PJ star, not PJ, it should be PJ star, right? So this you just substitute in here Q, then you, because the Q is independent of EJ, so summation is over J. That means EJ, right? Q is already a summation, right? Here you can say the summation over summation is nothing. It is going to remain the constant as far as we are concerned with this summation. That is why we can take it outside, right? And then what we do? So we are substituting minus 1 by beta. Sorry, 1 by kt as beta, right? 1 by kt as beta. Let me just write beta is equals to 1 by kt, where k stands for Boltzmann constant, right? And t stands for temperature. So we resubstitute it, we get this expression, then we do this, right? So this basically is the same expression, right? So what we are telling here is average u. Now onwards we are, so uh, this brackets represents average value, right? So instead of using this multiple times, we are just going to keep it as u. Okay, and then we are going to take the derivative of u with respect to beta, right, which will correspond to this, and then we take this inside the summation. Okay, right. So I think there has to be 1 by q, right? Here there has to be 1 by q, right? Here there has to be 1 by q, right? And then you take it. Okay, so you take it inside. Okay, you take it inside, you do the derivation. Okay, so what we have is, so we get the derivative as this. Okay, then what we have this expression, which is nothing but this, and then we resubstitute beta as this, and then d beta by dt will become this. This is nothing but 1 by k e to the power minus 1. So minus 1 will come outside, and it will become or 1 by t square, right? So then using this expression, this expression, this expression, what we can write is like this, which further quantifies as like this, and then we finally get this expression, right? It is nothing but algebraic manipulation, right? And this is option C. Okay, the correct answer is option C. So I hope the doubt is, nobody has any doubt, and you understood it clearly. If anybody has any doubt, they can ask now. Okay, and those who want to write it down, I'll give you a couple of minutes. Okay, meanwhile, if anybody has any doubt, they can ask. Okay. Nobody has any doubt. Okay, I'll give a couple of minutes to write it down. Okay. Okay, so nobody has any questions. Then we'll move on to the next question, right? Right. So next question is this: the expression for entropy. Okay, let me just. Okay. Okay. So the expression for entropy S as a function of partition function. What is it? I just told you in the previous previous to previous question, right? Q, where Q stands for partition function, S stands for entropy, K stands for Boltzmann constant, and T stands for temperature. Remember something I told, right? Like, I'm going to give a hint. Bridge equation. Yeah, bridge equation. Anybody got it? Yes, correct answer is option C, right? It's nothing but bridge equation, right? For NV and center, right? So this is a homework question which I am giving you. Okay. We can discuss it in the next class. Okay. So what is given? The simplest statistical mechanical system having cooperability is a three-level system shown below. Okay. So degeneracy basically means number of molecules occupying these energy state. So the number of molecules occupying energy equal to 3e, 3 epsilon is gamma, epsilon is 1, and having energy 0 are number 1. Okay. So what we have to find is an expression for the partition function Q as a function of energy E and degeneracy gamma is what? And temperature. Okay. Whether is it this, or is it this, or is it this, or is it this? Right. So I'll give you a couple of minutes to write it down, and then if we'll discuss it in the next class. Okay. I'll also give you the correct answer. Okay.
What is different?
So I hope everybody has written the question, right? So we'll move on to the next question. Okay. So what is this is also quite a lengthy question, right? So what we have considered a spherical non-polarizable molecule of radius 3 angstrom. So here A stands for angstrom. Okay. Having at its core, having at its center a dipole moment. Okay. Dipole moment is also present of 3d bar. The molecule is dissolved in a non-polar mixture. Remember, the solution or the solvent is a non-polar, whereas the molecule is polar, right? Having a dielectric constant equal to 3.5. Calculate the energy that is required to remove this molecule from the solution, right? The expression for energy is equal to this is the energy of expression. Okay, where A is the radius of the molecule, which is given as, I think, 3 angstrom. Epsilon r, this is epsilon, is the dielectric constant, which is given as 3.5, and mu is the dipole. Okay, what we need is energy that is required to remove this molecule, right? The options are this: 4.61 joule per mole, 2.33 joule per mole, 4000 joule per mole, or 2700 joule per mole, 2777 joule per mole. These are the options. Okay, I'll give you a couple of minutes to solve. Okay. Anybody able to answer this? Or you require more time? Okay, I'll give you a couple of more minutes. Anybody has answer to this? The correct answer is option D. Anybody got it? Okay, let us discuss the solution. Okay. So what we have is, consider a spherical. It is already given in the question that we have a spherical non-polarizable molecule of radius C. Okay. We are also given that E is equal to, this is the expression for calculation of energy. A is the molecular size, which is nothing but 3 Armstrong. We converted it into centimeter. So 1 Armstrong is nothing but 10 to the power minus 10 meter, which is nothing but 10 to the power minus 10 centimeter. Right. So then we write this A is, we converted it in centimeter. Why we are doing it CGS unit? Is because the dipole moment has been given in d bar. Right. So epsilon r is also given 3.5 and mu is also given 2d pi. So remember one molecule. So here the units are joule per mole. Okay. So we need to convert from molecule to mole. And what do we use for that? Right. We use this Boles, not Boles, but Avogadro's constant. Right. So I have also given you the unitary method. Otherwise, you can use straight away. Okay. So 1 mole occupies Avogadro number of molecules. Hence, 1 mole will be this many number of molecules. Right. You just calculate it. Okay. So when you basically put these values into this expression, you'll get this value, right? 4.61 into 10 to the power minus 21 joule. And because it is dependent on for 1 mole or 1 mole or 1 molecule, we just need to divide it by the appropriate conversion factor, right? When you do this, you get this expression. Okay. Anybody has any question? I'll give you all a couple of minutes to understand it. And if you have any doubt, you can ask me now, or you can even ask me later, but it's preferential that you ask me now. And for those who would like to write this down, I'll give you a couple of minutes, right? Okay, nobody has any doubts? Okay, then we'll move on to the next question. Okay, so what we are given is, let me change the color. Okay, what we are given is, we are given a two-state system in which the low energy is this 300 calorie per mole, and the high energy is 1500 calorie per mole, and it's a two-state system. Okay, a two-state system. Okay, and the temperature of the system is also given 300 Kelvin. So what we want is, what is the partition function, right? Whether is a partition function value is this, or this, right? If you know the definition of partition function and what this two-state model is, will be easily able to find the solution. Okay, so I'll give you a couple of minutes to solve it. Anybody able to got it? Anybody got it? Okay, so I'll be revealing the answer. The answer is this, right? So just like in here, instead of, here we have three level system, right? So if you will be able to answer this question for three level, this is a simplified version of this. Instead of three, here we have only two level system, right? So the correct expression for the partition function will be this, right? 1 plus e to the power minus of epsilon 2 minus epsilon 1 divided by kt. So then you just put in the values. We are given the energy 1500, 300, okay, and 2 into 300. Temperature is also given. You just put in the value, you get it 1 plus e to the power minus 2, which is nothing but this value. Right? So correct answer is option C, right? So anybody has any doubt? So for those who would like to write it down, you can write it down, and those who want to who have any question, they can ask, and for others, you can try the next question. This is the next question. Okay. Okay, so nobody has any doubt? And we'll move on to the next question. So what is the next question? So this is the next question. What we have is, okay, let me change the color. Okay, so the experimental studies for a simple non-polar, okay, non-molar gas molecule, gas A. Okay, so gas A is non-polar. Indicate that when two molecules of species A are two molecular diameters, that means 2 sigma, right? Sigma basically represents the molecular diameter. The potential energy is E. This is the potential energy in Oaks. Consider now two simple non-polar molecules of species B. Okay, when these two molecules are two molecular diameters apart, what is? So here it is. What is the potential energy in Oaks? And then consider the general function to be Lennard-Jones potential. Okay, so what is Lennard-Jones? That is 4 epsilon. So what is, let me rewrite it. So Lennard-Jones is basically energy, or you can write it U, ULJ, okay, which is a function of Rij, right? Relative separation between the two molecules is what? 4 epsilon Ij, right? Into sigma by R to the power, yes, 12 minus sigma by R to the power 6, right? So critical data has been given. Critical, so TC stands for critical temperature in Kelvin. PC stands for critical pressure in bar. VC stands for critical volume in centimeter cube per mole, right? So for A, these are the values, and for B, these are the values. Okay. So this question is what? Yes, this question will be dependent on, could be solved with theory of corresponding states, right? These are the option -12 into 10 to the power -6. So the answer will be in ox, right? In ox. That is because it is mentioned here ox, we have not put it in here a, right? Whether it is -12 into 10 to the power -6 or -19 into 10 to the power -16 or -52 into 10 to the power -16 or -112 into 10 to the power -16. Use what? Use theory of corresponding state, right? So I'll give you a couple of minutes to solve it. Okay. Anybody got it? Anybody got it? The correct answer is option A, right? Okay, the way we solve this, correct answer is option A, minus 12 into 10 to the power minus 6. Okay, so we are given that energy of interaction for molecule A for two molecules having A molecule is this one. Okay, so by theory of molecular theory of corresponding state, what we have is this expression where F is some functional form of energy. So for here we have given is F is a Lj potential, right? So what we do, we just take the ratio of these two things for two molecules, okay, and for F is nothing but Lj potential, right? F is Lj potential, and epsilon by k is nothing but this, right? Expression, we put in the values, okay, we get tau. So tau here basically represents the energy of interaction, right? So we end up with minus 12 is 10 to the power minus 6. Okay. So anybody has any doubt? So I'll wait for a couple of minutes. If you have any doubt, you can ask. Otherwise, for those questions who don't have any doubt, they can go move on to the next question, which is a probability based question. And those who want to write it down can write it down. Okay. Okay. Nobody has any questions, so we'll move on to the next question. Okay. So next question is, suppose that on a given day, you sample the distribution of colors of socks. Okay. Sample color of socks that 30 people, okay, were wearing. So figure 1 shows the possible outcome. The entropy can be computed for any distribution function, even for colors of socks, which is white, green, black, red, and brown. Calculate the entropy of this distribution. So this is the distribution. The probability of having a white sock is 2 by 10. Probability of having a green sock is 1 by 10. Probability of having a blue sock is 3 by 10. Probability of having a red sock is 3 by 10. And probability of having a brown sock is 1 by 10. Right? So the correct options are this: 0, 0 Kelvin, 1.5, 5.5, or 8.5. Okay. So I'll give you a couple of tips to solve it. Okay. Anybody able to solve it? Right? Anybody able to solve it? The correct answer is option B. Right? Let me change the color. Option B. Right? So what we have is the expression is nothing but S by P is nothing but equal to summation of Pi, Ln Pi, right? And here the loop will run for, because we have five outcomes, summation will be from different color of socks, that is 1 to 5. This is nothing but, so we have been given this probability 2 by 10 is nothing but 0.2. So we just put in the values, right? Minus of summation of this, right? So here has to be minus, which ends up with this value 1.5, 1.5, right? So k we just multiply. K stands for Boltzmann constant. So this should be small k. Okay, this should be small k. This should be small k, and this also should be small k. Right? Okay, for those of you who have no doubt, they can try the next question, and those of you who would like to write can write, and if you have any doubts you can ask. Okay. So nobody has any questions, so we'll move on to the next question. Okay. So what is the two molecules? Okay, so two molecules are adsorbed on a simple two-dimensional square crystalline lattice, each at one particular lattice. Okay, so there are in total three lattices. Okay, where the molecules can adsorb. If two molecules at the adjacent side, attractive interaction between them can result in a negative potential energy. Right? If the molecules are adjacent, then the energy of interaction will be minus epsilon. Otherwise, the molecules do not interact. Consider the volume to be fixed and neglect all other energy, such as kinetic energy and those of molecules with surface. What is, so sigma stands for epsilon. Sigma stands for multiplicity. What are the total number of ways of having a zero molecules, arrangement of molecules in this square lattice, so that the energy of interaction is zero. Right? So these are the total number of ways. So this is one question, and the next question is also related to this question. Okay. So I will be explaining both of them one after the other, right? So the option which we have is 4v, v into v minus 1 minus 4v, 4v by 2, v into v minus 1 minus 4v by 2. Okay, so where v stands for volume, v stands for total lattice size. Okay, so I'll give you a couple of minutes to solve it. Anybody got it? The correct answer is option. Which one? Anybody has answer? So we'll discuss, right? Intentionally, I have left this blank because I will discuss both of these questions one after the other, right? Right. So this is the first question, and this is the second question. Total number of ways of arrangement of molecule said that the total energy is minus epsilon. Right. So I'll give you a couple of minutes for you to solve. Hmm. Anybody got it? Okay. So let us discuss. So what we have is for both of these problems, we must think that about what microsets are possible in system. Okay. Some possibilities for a system with V are shown in figure 12, right? So these are the possible microstates, right? So this is the lattice, right? The square points represent lattice, and these are the number of these are the molecules. So one number represents first molecule, two number represents two molecules. So like it said, if molecules are adjacent, energy of interaction is minus. So we can have an energy of interaction minus here. There is no energy of interaction here also. They are not adjacent. They are diagonally opposite, but they are not adjacent. So energy of interaction is zero. Here they are adjacent, so energy of interaction is minus epsilon. Similar goes with this. Okay, so some microstates for two molecules adsorbed onto a square lattice. Okay, we notice that each lattice side has a total of four neighbors, right? So if you consider, let's say for example, this lattice side, it has this, and this, where energy of interaction will be minus epsilon. Here, or here and here diagonally, we will have zero energy of interaction. Okay, so this is for a molecule in the bulk. If we have a on corner, we might have only three energy of interactions, right? Like similar goes for here, only three. Similar goes for here, right? Same goes for here, right? So for two, it will be this one, and this one, right? With the exception of eight sides, right? However, the number of eight sides will be much less than a total number of sides, which are V, in a microscopic system. Because in a microscopic system, what we have total number of sites will be 10 to the power minus 23 molecules. Right? Therefore, we will neglect all such edges, right? So the number of possible uh, uh, microstate for energy equal to E is simply the total number of ways we can place the first molecule, which will be V, multiplied by total number of possible neighbors to it, which will be multiplied by 4. Because for each molecule, let's say for example, we put the molecule in here, total number of ways of putting second molecule will be either this, or this. So total number of ways of putting first molecule will be nothing but total number of molecule size, right? Total number of molecules, because number of lattice parameters are very high, right? That is V multiplied by, for each molecule put, we have four other options, right? It is 4. So this is our option. This is answer to the first question, right? But no, this is not the answer to the first question. Okay, because molecules are of same nature. If that is, for example, if first molecule is hydrogen, second molecule is also hydrogen. So basically, molecules are indistinguishable. So like I told in the first question of our class, that when the molecules are indistinguishable, we have to divide by, right? Because we are counting it again. Like for example, here you see this and this is same thing, because here we have represented that molecule one is one is two. That is, we have made the molecules as indistinguishable, right? So we have made molecules as distinguishable, whereas in reality molecules will be indistinguishable, right? They are same. So in that case, we have to divide. So this is the answer to the first question, right? This, which is 4v by 2, right? And then the other is what is for total number of microstates for energy equal to minus epsilon. This will be what? On the other hand, all remaining possible configurations have zero energy, right? The total number of configuration is the number V of the spots at which to put the first molecules times the number of V minus 1 spot at which to then place the second. So this is the total number of ways for for the second option, that is total number of ways of putting molecule so that the energy of interaction between them is minus epsilon, is zero. Energy of interaction is zero, right? It is nothing but total number of ways minus the what we have number of ways which we have found for first earlier question, right? But again here the molecules are indistinguishable, so we have to divide by two, right? So this is the answer to the second question, right? So this, right? So does anybody of you have any doubt, right? If you have any doubt, you can ask. Otherwise, for those of you who don't have any doubt and want to write this down, I'll give you a couple of minutes to write it down, right? Right, so you can start writing from here. So anybody of you any doubt? Okay, I'll move on to the right this part. Right, you can start writing this down. Nobody has any doubt? Anybody has any doubt? If you don't have any doubt, for those who do not have any doubt, they can go on to these questions, right? For those who want to write, they can write, right? Okay, no questions. I hope that everybody written it. Okay, so then we'll move on to the next question. Okay, so this question is common. The information for this question is common for question 13 to 16. Okay, so what is the question? Let me change the color. So n particles, okay, are adsorbed on the lattice consisting of v possible adsorption site, with given that number of molecules are very sorry, that number of molecules are very smaller as compared to the number of lattices. Okay, write an expression for the number of distinct molecule configuration in the system in the following cases. Right, only one can sit at each site, and the particles are all identical. Right, this is a follow-up question for the previous question. Right. Okay, so this is the first question. The second question is only one particle can sit at each side, and the particles each have a unique identity. Right? Only one particle can sit, and each side the particle have unique identity. For example, different colors. This is the 14th question, and the 15th question is more than one particle can sit at each side, and the particle each have a unique identity. So we'll move on to the step in a step-wise manner. So first you try solving this question in which only one particle can sit at each side, and the particles are identical. Okay, I'll give you a couple of minutes to solve the question. Okay. Anybody got it? So the correct answer is, I am not providing any answers, right? The correct answer is this: total number of ways is nothing but p factorial by n factorial into b minus n factorial. Anybody got it? So what is the explanation? I hope you will get it after you hear the explanation. Okay. What is the explanation? So in this case, we have B options in total, right? We can think of a process of selecting n of the B sites and then placing particles on them. Since the particles are identical, okay, the order which we put them on site does not matter. In other words, if we swap to particles position, we do not incur a new configuration. Hence, the total number of ways is this. We factorial that will be VCN, which is nothing but this value. Right? Total out of B sites, we are choosing N sites. And because the particles are identical, right, we are using the C. Otherwise, we would have used the P. That means because the number of particles are identical, that is why this N factorial has come out. If the particles would not have been identical, we would not have been using this N factorial, right? So anybody of you got this answer? Right? Nobody got it. So if you want, so for those who have any questions, they can ask. And those who would like to write it this down can write down. And for those who knows who want to try the next question can try the next question. So it is okay. So I'll give a couple of minutes. Okay. So nobody has any doubts. So we'll move on to the next question. So the next question is, in this case, only one particle can sit at each side, and the particles each have a unique identity. Right. So what we will do, you can take inspiration from previous question. That is question number 30. You can try to answer this question. Right. I'll give you a couple of minutes to try it out. Okay, the correct answer is only you just because the balls are not identical, they are distinguishable. We just multiplied by n factorial. Right, so the correct answer will be nothing but this. Right, total number of ways of picking n points from v points. Right, VCN multiplied by n factorial. Right, nothing but VCN multiplied by n factorial. Right, this will give this answer. Okay, the next question is this: more than one particle can sit at each side, and the particle each have a unique identity. Right, you can try it out. Okay, anybody got any answer? Okay, so I'll keep giving the answer. So this is the answer, right? Why is that? This scenario is equivalent to the one in which particles do not interact and thus do not see each other, right? Do not. Every particle has v possible locations, and the independence of their position means the total is multiplicative. Give me any question. Okay, so we'll discuss the question number 16. So more than one particle can sit at each side, and the particles are all identical. Remember, they are all identical. So the answer is this one, right? n plus b minus 1 factorial divided by n factorial into b minus 1 factorial. Okay. So what is the, this is the trickiest case of the four, right? It is helpful to consider a specific example to illustrate the complications. Let us take this. It is easy to say that because there are only three distinct states, both particles in the first side, both in the second side, and one in the each side. However, the expression v by n fails here, giving this many, right? Hence, it turns out that the correct explanation is expression for in fact is this one. Now, how do we come it? Let us do it. Let us check the uh, how do we get this expression, right? So proof for this expression. So what we consider is we consider a box and number of balls in it. Okay. So figure A represents balls in a box and figure B represents if the box had a movable partition in it, right? So there are four ways to partition in n is equal to 3 balls into. So first let us proof of this. So how many ways can an indistinguishable particle, okay, indistinguishable particle be put in m boxes, right? So this is box number 1, box number 2, such that we have m boxes and number of particles are n, and the particles are indistinguishable, right? With any number of particles in box. Okay. This type of counting is needed to predict the properties of particles called bosons. So I'm giving also a practical example. Okay. Bosons such as photons, and helium atoms, right? Bose-Einstein statistics counts the way that n particles can be distributed in m different energy levels when several particles can occupy the same same quantum mechanical energy levels. For now on, our interest is not in the physics, but just in the counting problem. Okay. So figure this figure, right, shows that one way to count the number of arrangement is to think of a system as a linear array of n particles interspersed with m minus 1 movable parts, right? So if that the partition system into m boxes, right? So let's say if we have this line, if you want to partition it in two ways, you'll put one box, right? If you want it in three, we'll put two walls, right? So for the because we have m boxes to partition it, we are using m minus 1 movable ones, right? And there are m plus n minus 1 objects, right? Counting walls plus particles, right? If the objects were all distinguishable, there would be m plus n minus 1 factorial arrangement. However, because here the n particles are indistinguishable from each other and the m minus balls are also indistinguishable from each other, because of this, the what we can write is n plus b minus 1 factorial total number of ways divided by, because n balls are identical, we have to divide by n factorial, and because v minus 1 walls are also identical, we have to divide by v minus 1. So p, or here v can be replaced with m also, right? Giving rise to this. Right? So the correct answer is this one. Right? So if you have any doubt, you can ask it. If you want to write it down, I'll give you time. Okay, you can write this down also. Let us move on to the next question. If you do not have any doubts, okay, this is also probability based question and it's a linked question. So information is going to remain same for question number 17 and question number 18. Okay. So what is the question? So you have applied for 3 schools. Let's say the schools are University of California at San Francisco, which is denoted as UCSF, Dutch School of Mine, DSM, and Harvard. Okay, you guess that the probabilities you will be accepted are probability of acceptance into UCSF is 0.1, probability of getting accepted in DSM is 0.30, and probability of getting accepted in Harvard is 0.50. So you are 50% likely to get accepted in Harvard. So assume that the principal acceptance events are independent. So what the question is, what is the probability, okay, that you get in somewhere? Okay, probability of either you get at UCSF or DSM or Harvard, any of them. Okay, so there is no option for this question. Okay, so I'll give you a couple of minutes to try it out. So everybody got it? Okay, so let me start discussing. The simplest way to solve this problem is to recall that when probabilities are independent, okay, and you want the probability of events, let's say the events are A and B, you can multiply it, right? When events are mutually exclusive, and when events are mutually exclusive, so probability of A and B occurring simultaneously will be probability of A multiplied by probability of B, right? So when and you want the probability of events A and B, you can add them, add the probabilities. Therefore, we try to structure the problem into and or problem, right? We want the probability of getting into Harvard or DSM or UCSF, but this doesn't help because these events are not mutually exclusive. Mutually exclusive, what does it mean? That if one happens, the other cannot happen. So we try again. The probability of acceptance somewhere is probability of A, right? Which is nothing but one. Probability of acceptance is nothing but one minus probability of rejection, where P of R is, right, probability that you have been rejected somewhere. You are either accepted somewhere or you are not. But this probability can be put in about terms. P of R is equal to the probability that you are rejected at Harvard and at DSM and at UCSF. These events are independent. So we have the answer. The probability of rejection at Harvard is P of RS is nothing but 1 minus probability of acceptance, which is 1 minus 0.5, which is nothing but 0.5. Rejection as DSM is nothing but this 1 minus probability of acceptance, which is already given as 0.3, right? So 1 minus 0.3 is 0.7. Rejection at UCSF is 1 minus 0.1, which is nothing but 0.9. Therefore, probability of rejection is nothing but probability of rejection at UCSF multiplied by probability of rejection at DSM multiplied by probability of rejection at Harvard, which is nothing but this, which is never 0.315. Therefore, the probability of at least one acceptance is nothing but 1 minus P of R, which is nothing but 1 minus 0.315, which is 0.685. Right? So correct answer is 0.685, right? 0, 0.685, right? If you have any doubt, you can ask, right? For those of you who want to write, they can write. And for those of you who want to ask, they can ask any doubt. And for those of you who would like to go ahead, can try the 18th question. Okay. I'll give you a couple of minutes. Okay, we'll go on to the next question, which is what is the probability that you will be accepted by both Harvard and Duluth, right? So I'll give you a couple of minutes to try this question. So anybody got it? Nobody got it? Let us discuss this. Okay. The simple answer is that, let me, okay, the simple answer is that this is the intersection of two independent events, which is probability of getting accepted at Harvard multiplied by probability of getting accepted at DSM. This is nothing but 0.5 multiplied by 0.3, which is nothing but 0.15. This is the one of the ways of doing it. The other way would be a more mechanical approach to either part A or this part is to write down all the possible circumstances. Rejection and acceptance at H are mutually exclusive, right? Harvard. H stands for Harvard. Their probabilities add to 1. The same for the other two schools. Therefore, all possible circumstances are taken into account by adding the mutually exclusive events together and multiplying the independent events, which corresponds to this expression. Right? Or equivalently, we can write it like this also, where the first term is the probability of acceptance at all three. The second term represents acceptance at Harvard and DSM, but rejection at UCSF. The third term represents acceptance at Harvard and UCSF, but rejection at DSM, so on and so forth. Each of these events are mutually exclusive, with respect to, of course, with respect to each other. Therefore, they are all added, right? Mutually exclusive, right? Each individual team represents independent events, right? For example, acceptance at Harvard and acceptance at DSM and acceptance at UCSF. Therefore, it is simple to read off the answer in this problem. We want acceptance at Harvard and acceptance at DSM. But notice we don't care about UCSF, right? So this probability is nothing but this one, right? Which is nothing but 0.5 multiplied by 0.3. Okay. So if anybody has any doubt, they can ask. Otherwise, you can try to solve the next question. I'll give you a couple of minutes. Okay, so let us start with the next question as I hear the no doubts. So what we have is a scientist has constructed a secret peptide to carry a message. You know only the composition of peptide, which is 6 amino acids block. It contains one serine, okay, one threonine, one cytosine, one arginine, and two glucamates. What is the probability that the secret will occur by chance? Sequence secret will occur by chance. Okay. So I'll give you a couple of minutes to solve the question. Okay. Nobody has. So we'll start. We'll start. Anybody has got the answer? Okay. So we'll start with the explanation. So this is the answer, right? So the S could be the secret could be in any one of the six position. Sorry, the serenine could be in any one of the six position with equal likelihood. The probability that it is in position 1 is 1 by 6. Given that S is in first position, we have two E zeros which could occur in any of the remaining 5 positions. The probability that one of them is in position 2 is 2 by 5. Okay? Given those two letters in position, the probability that one C is in the line of 4 remaining position is 1 by 4. The probability for R is 1 by 3. For remaining E, it is 1 by 2. And for the T is 1 by 1. The total number of ways will be 1 by 6. Total probability will be 1 by 6 multiplied by 2 by 5 multiplied by 1 by 4 multiplied by 1 by 3 multiplied by 1 by 2, which is nothing but 1 by 360, which in factorial form could also be written as this. Okay. So if anybody has any doubt, I'll give you a couple of minutes, right, to solve it. And for those who do not have any doubt, they can try with this question number 20 and 21. Okay. Okay, so I hear no question, so we'll move on to the question number 20. Okay, so question number 20 is what is the probability? So suppose you roll out a pair six-sided die 3 times. What is the probability of getting a 5 twice from all 3 rows of dice? Right, this is a fairly easy question, right? So I'll give you a couple of minutes to solve it, and then I'll explain. Okay, so the correct answer is the probability of getting 5 x 5 on n rolls of dice is nothing but this 1 by 6 whole to the power x multiplied by 5 by 6 whole to the power n minus x multiplied by n factorial divided by x factorial into n minus x factorial, right? So note that this is a 2 outcome problem. Okay, getting a 5 or not getting a 5. It is not a 6 outcome problem. So the probability of getting 2 5s on a 3 roll of dice is nothing but 1 by 6 whole square multiplied by 5 by 6 whole to the power 1 multiplied by 3 factorial by 2 factorial into 1 factorial, which corresponds to with this, right? If you have any doubt, you can ask. Otherwise, you can go to the next question. Okay. So I hear no question. So we'll go with the last question. What is the probability of getting a total of at least 2 5s from all 3 rows of dice, right? So the solution is probability of getting at least 2 5s is the probability of getting 2 5s or 3 5s. Since these two the situations are mutually exclusive, we seek probability of getting 2 5s plus probability of getting 3 5s, which corresponds to this expression. And when we simplify, we end up with this. Okay. Okay, we end up with this expression, right? So I thank you all for attending this class, and I hope you have cleared some of your concepts. And this uh, tutorial will help you to solve your assignment problems, right? So if you have any doubts, you can ask now. I'll wait for a couple of minutes. If nobody has any doubts, they can leave. And for those people who have doubts, they can stay and ask the doubts, right? So I'll wait for a couple of minutes, right? Okay, so nobody has any doubts, right? Okay. So I thank you all for attending this session, and I hope to see you again in the next class. Okay. Thank you. I'll be stopping the meeting now, right? Thank you all.